Utility power provides energy to run electrical equipment of all kinds. One of the simplest electric devices is a light bulb, like this one. When utility power stops for any reason, the light goes off. An uninterruptible power supply, usually called a UPS, provides backup power when utility power fails or is switched off. Installation is simple. Plug the UPS into a regular outlet, then plug the electric equipment into the UPS. When utility power is on, it passes through the UPS and goes to the equipment. During normal operation, a UPS also protects equipment against sudden power surges or spikes. When utility power fails or is switched off, the UPS switches to battery power instantly. The equipment keeps working. A computer is much more complex than a light bulb. It needs clean and consistent power to run efficiently. Also, the voltage of utility power often fluctuates. It has overvoltages and sags, fractions of a second with too much or too little voltage. UPS systems with automatic voltage regulation, or AVR, detect and correct these voltage fluctuations immediately. The equipment receives clean, consistent power at all times. In severe weather or during peak demand, utility power can have serious fluctuations. At times like these, the UPS will switch automatically to battery backup power. A UPS system will replace utility power for a few minutes to several hours, depending on the capacity of the UPS and what equipment is connected to it. At minimum, this gives computer users enough time to save their work and shut their computers down safely. Active Power Factor Correction, or Active PFC, improves the energy efficiency of power supply units in newer and higher-end computers and electronics. For example, any equipment with ENERGY STAR certification has active PFC circuitry. This technology is becoming widely used, and it requires even more consistent power. When it receives direct utility power or pass-through power, equipment that uses an active PFC circuit will function as it should. When it receives power from a backup battery, however, it may not work correctly. Here's why. Utility power arrives as a sine wave, a smooth continuous movement between positive and negative polarity. Devices with active PFC circuits are designed to work best with sine wave input. Many UPS batteries produce a simulated sine wave output, which approximates the shape of a true sine wave, but with moments of zero voltage as the polarity changes. These power gaps may create stress on the equipment, reducing its useful life. An active PFC circuit may detect the gaps as a loss of power and shut down the equipment without warning. This can result in equipment damage, data loss, or both. A UPS system with true sine wave output meets the demanding requirements of equipment with active PFC circuits. It ensures reliable operation and peak performance.